Hello, student, and to all of the viewers that who wanted to learn math. Welcome to Math 8 Calculus 3. Our topic for today is all about partial derivatives of higher order. So, let's start. Note that the order that we take the derivatives in is given by the notation for each. For subscripting, we have this notation f sub y sub x and differentiate them left to right. For fraction notation, we have this one, the quantity of or the derivative of x, the derivative with respect to x, the quantity of x squared f all over um the derivative of with respect to x and with respect to y. Differentiate them moving along the denominator from the right to left. Okay? Let us have an example. So, example number one, um, find f with respect to x, x, y for f, the quantity of x and y is equal to x cubed plus 3x squared y plus y squared. So we have this formula, f sub x sub y is equal to first, or we have the partial derivative with respect to y, like what I have said earlier, the partial derivative all over the partial derivative with respect to y, the quantity of um, a squared f all over a squared ax squared. Okay, let's have step one. So our first step is we have to derive in terms of x. We have um, x, y, and our first step is to derive with respect to x. So we have um, this one, a over ay, we interchange y into x because we are um, our first step is to derive with respect to x, diba? So i-change lang nato ang y into x, and then from the given, this given, we have x cubed plus 3x squared y plus y squared. Um, we have to derive all of the x in the given, um, and those remaining will remain constant. Okay? So from this given, we have now 3 3x squared plus 6xy. This is our answer from deriving f in terms of the first x. So next step is in step 2, we have to derive f in terms of x and x, the second x. Okay? Um, Again, we have to substitute a all over ax because we are deriving x. So the given now is from this step 1, we have 3x squared plus 6xy. So again, we have to derive those who have x and the rest will remain constant. So we have this one, 6x plus 6y. So let's proceed to step 3, which is we are deriving now the last one, which is the y. So we interchange the x into y from this one, and the from the step 2, we have 6x plus 6y. By deriving this, we came up with 6. So 6 is now the answer. So let us proceed to step 2. find now we have the, three variable with double x. Find f, x, x, y, and z. For f, we have x, y, and z is equal to z cubed y squared I in x. So remember that the derivation of I in x is 1 over x. So let us proceed now. We have f of x because we have to derive first the first x. Again, substitute. We have the partial derivative with respect to x from the given x cubed y squared and I in x. So we have to derive all of those terms that has x. So in this given, we only have I and x. So um if we are going to derive I and x, we came up with 1 over x. So we have now z cubed y squared 1 over x. From simplifying, we get this one, z cubed y squared over x. So next step, we have to derive with respect to f, x, and x. Again, we have to replace, we had the partial derivative with respect to x. So from the first derivation, we have this z cubed y squared all over x. By simplifying or in deriving with in terms of x, we have negative z cubed y squared all over x squared. That is the second step, and this let us proceed to deriving in terms of y, which is um the third term or the third variable with this one fxxyz. Okay, we have to derive with in terms of y now. Replace the partial derivative with respect to y. From the second step, we came up with negative z cubed y squared all over x squared. By deriving with in terms of y, those terms who have not y or will remain constant. Remember that, students. And we came up with negative 2z cubed y all over x squared. So the last one, we have to derive it in terms of z. So let us replace the partial derivative with in terms of z. We came up from the third step with this. So we have 2z cubed y all over x squared. By deriving, we came up with negative 6z squared y all over x squared. This is now the answer. Okay, again, hope that you learned something in this video. Thank you and God bless everyone.